So this is graph bipartite. And what this is basically asking is if you can split its set of nodes into two independent subsets so that every edge of the graph has one node A and the other node B. The common way to solve this problem is to use a coloring method. And so you keep track of each node, and either a node is not colored or it is colored with, we're just going to keep track of it with a 1. And then every node that is touching that node that is marked as 1 is a -1. So the best solution that I've seen is to use DFS. And first, to keep track of all of the nodes, we just need an int array, and we're going to call it color. And it's going to be the length of the graph. That's how many nodes are in it. And so then we'll go through each node in the graph. So when we initialize this array, all of the values are at 0. So that's how we can know that we haven't looked at a node in our array yet, because we're keeping track of it with this color array that we made. So if our node that we're looking at hasn't been looked at yet, that's at 0, and then if we do a DFS on that node, and that is negative, we are going to return false. But if we get through that DFS, all we're going to do is return true. So what is our DFS going to look like for that node? Well, we're going to take in the original graph because we're going to traverse it there. We're going to use our color array because we're keeping track of which ones we looked at. We're going to pass the index of which array we are currently on. And then we're going to pass another thing called the color, which will be either a 1 or a -1, because we're going to check that it's the right color to be. So when we go here, we're going to be passing our graph. We can just, our color array, our eye, and then the color that we want it to be, we could just start it off as 1. So let's look at our DFS. So if the color that we're on, if the node that we're on, which is I, and it's been looked at already, that means it's not equal to 0. So it's been colored already. So what we're going to do is return if this node is the color that it's supposed to be, which is to be. So if it's not 0, it's supposed to be 1, which is what we have here. So that's that. So else if our color I is 0, first thing we're going to do is we're going to color it the color it's supposed to be. So color I is supposed to be So then we can traverse every node that is connected to this current node. So we could say for int j, we're just calling it int j, which is in every graph I. So all of these ones, this is the color it's to be. So we're coloring this one 1. So, but all of the ones that are adjacent to it, they're supposed to be -1. So if they're not -1, which we're just going to say it's graph color j, and then we're just going to call it negative, because that will be -1 for here, and then even if it's -1, it'll switch it back. We're going to return false. Otherwise, if it gets through all of that, we are going to return true. So what this is doing is it's finding a node that isn't colored, and it's calling DFS on that. So it's saying, okay, if it's not colored yet, we're going to make it this one. But then what it's doing is calling DFS also on all of its children, and either coloring it or checking that it's or returning false if it's if it's not colored the right one. So if it's not colored the right one here, it's going to return false. And anyway, that should work.